So we were founded Marine Savers in the early 2000s, but the turtle component of our project, so the Marine Sea Turtle Conservation Programme, started in 2010. Since starting, we've rescued and rehabilitated over 450 turtles, and we've also got several avenues of ongoing research. One of the things we've been doing recently is looking back at our admissions data. And even though, as it's been pointed out in previous talks, that green and hawksbill turtles are the most commonly sighted in the Maldives, 75% of our admissions are actually olive ridleys. And 3/4 of these are found entangled, with a further around 20% showing signs of previous entanglement. The other 25% of our admissions is split roughly equally between the green and hawksbill turtles. Our green turtles are mostly given to us after being kept as pets, so quite a high proportion of these are post-hatchlings or very young juveniles. Our hawksbill turtles are mostly brought to us after being found floating, and we're currently investigating this to see if there is an underlying cause. Another thing that's come from our admissions data is noticing just how many of the turtles that are reported to us come directly from people that have a direct stake in the tourism industry. So over 70% of our stranding reports are made by resorts and another 18% by third parties. So this is people like dive operations and resort biologists. But what's most striking about this figure is just how few of our turtles come to us from local stakeholders. So people that don't have a direct input into tourism, and it's just 4%. So another thing that we're doing just now is working on improving our local outreach. And this is going to be mainly focused around local islands to try and improve that number a bit. Another of the projects that we've been working on recently is our satellite tracking program. And this was started with the aims of assessing the survival of sea turtles after they've been rehabilitated and released, and also to look at foraging grounds to try and identify areas that might need a little bit more legislative protection. So our first tag was attached 10 years ago to the very imaginatively named Olivia, who was a female olive ridley turtle. And since then, we've attached about 32 tags. And we've been mainly focusing on juvenile green and olive ridley turtles because we identified these groups as lacking in the literature. And we found that our turtles do pretty well after they're released. The average distance that they travel before their tags fall off, which is normally about 3 months, is about 3,000 kilometers. However, we've had some turtles swim over double this, and with one moving over 7,200 kilometers. And they're pretty fast as well. So the green juvenile turtles, they travel around 37 kilometers a day on average. But again, we've had some that are a lot faster than this and travel around 57 kilometers a day. The olive ridley turtles are a bit slower, but that's just a species difference, and they're still pretty fast, really. And this map is showing some of the tracks that the trails that our olive ridley turtles have made. So on the left-hand side and lower down, you can see where the Maldives is. And one of the first things you can notice is that the turtles all seem to head in different directions. But we've actually found out that the direction that the turtles swim in after they're released is dependent on the time of year that they're released. So turtles that are released between April and September during the southwest monsoon currents are much more likely to travel east, whereas turtles that are released between November and March even, are more likely to head either north or west. And it's just to do with the shift in currents. But the most exciting thing that we've found from this data are these kind of areas here. And within these boxes, you can see that the lines that the turtles have made as they've been moving around become a lot more squiggly. And that's suggesting to us that the turtles are spending a lot more time feeding in these areas. But what's really exciting is that all of these areas correspond with deep sea ridges or plateaus where the ocean seafloor is raised, even though it's still thousands of meters deep. And our theory is that as these areas of floor rise, they create upwellings and create a really high abundance of food that the turtles are then feeding on. And then this is some of the tracks from our green turtles. And again, you can see, similarly with the olive ridleys, they head in quite different directions. But again, the directions that they're heading in is completely dependent on the prevailing currents. And again, similarly with the olive ridleys, in these same areas, we have this feeding behavior, and it's particularly prominent on this right-hand side, then this deep sea ridge off the coast of Indonesia. You might also notice that down the bottom, we have this orange track that seems to disappear off the corner of the screen. And that's because this little turtle, by the time her tag fell off, she traveled over 6,000 kilometers and was over halfway to Australia. So obviously the satellite tracking program is great for the turtles that we release, but we have some turtles that we aren't able to release. So for that, we've got our Flying Turtles program. And this was started with the aim to send non-releasable patients to aquariums and sea life centres around the world, so that they can act as ambassadors for their species and also contribute to kind of global awareness of the threats to sea turtles. So I just want to share one turtle story with you in particular. Peggy the turtle was an olive ridley who was found floating and with her front left flipper missing in August 2014. Because she was floating, we deemed her as non-releasable because we felt that she wouldn't be able to feed herself and survive in the wild. So in August 2016, as she was still floating, she was transported to Belgium. And then thanks to the hard work of the team there, in early 2019, she actually started diving again and was soon comfortably resting on the bottom of her pool. So in June of that year, she was transported back to the Maldives, where she was released from Kudahura with a satellite tracker attached. And this is where she went. So you can see she passed around the south of Sri Lanka and then up north, up to India. And this area of India that she ended up in is actually one of the regions that olive ridley turtles are known to nest in. And we're not sure entirely from her track whether she went ashore and actually nested, but this is such a positive thing for us to be able to see that even after 5 years of rehabilitation, that turtles can be released and not only survive, but go on to potentially contribute to the breeding population going forwards. That's the end. You're welcome to ask any questions during the question and answer session later, or you can also contact me directly as well, or visit our website if you want more information.